Welcome back to Raw Machines, your journey to discover the most impressive processes from around the world. Today, join me behind the scenes of the maritime industry, where steel giants are constantly maintained, upgraded, and reborn. From massive dry docks to the deep ocean floor, we will reveal how humanity maintains, upgrades, and redefines these transport machines. Let's get started.
Three, two, one, go. Step away.
Hull cleaning is one of the silent yet critical tasks in the maritime industry. The most common method involves bringing the vessel into a dry dock, but the cost for each session is substantial, ranging from 1.2 to 1.6 million US, not including indirect losses incurred when the ship remains out of service for too long. To address this, alternative solutions have been developed, most notably underwater cleaning performed by divers. This is part of ship husbandry and operations, which allow the hull to be cleaned even while the vessel is at anchor. However, behind this solution lies a world full of risks. They must work in dark, polluted environments, often alone, and constantly face dangers from tides or the movement of the ship. That is not all. The cleaning process can release heavy metals like copper and zinc from the paint, causing negative impacts on the marine ecosystem and creating biological imbalances. Consequently, current trends are moving toward solutions that are both effective and environmentally friendly. Underwater robots or drones are gradually changing how the maritime industry approaches this issue. Instead of using mechanical brushes, new devices utilize strong suction or high-pressure water jets to remove biofouling, while simultaneously collecting it to limit dispersal into the environment. This is a significant step forward, helping to protect both the vessel and the ocean. On an even more extreme level, there are saturation divers who work at great depths for extended periods. They live in cramped pressure chambers for weeks, breathing special gas mixtures and working shifts as undersea laborers. This job requires high endurance and carries many risks, essentially functioning as a long-term mission in an environment completely alien to humans. For this reason, ROVs, remotely operated underwater vehicles, are seen as the future of the industry. They can work at great depths without needing rest or decompression, almost entirely eliminating risks to humans. However, to operate them effectively requires a team of well-trained technicians who understand both the technology and the marine environment.
No, non tieni niente con i tiri.
No, ce l'hai tu?
Sì,
Ah no,
sì.
non boccio lui. Te lo riprendere anch'io.
In summary, hull cleaning is not just a simple maintenance task, but a complex puzzle involving economic efficiency, labor safety, and environmental protection. In the future, with the support of technology and automation, the maritime industry will move closer to safer, more sustainable, and more efficient solutions. This footage documents the dry dock maintenance of the TI Europe, one of the 4 largest supertankers in the world, operated by Euronav. Measuring nearly 400 meters in length and 68 meters in width, maneuvering this colossal vessel into the repair dock is a high-stakes challenge. Every movement requires surgical coordination between the pilot and the tugboats to prevent any contact with the dock walls. Once the ship is perfectly centered, the floating dock begins to pump out its ballast water. The vessel slowly descends until it rests securely upon the massive keel blocks at the bottom of the dock. At this stage, the entire submerged hull of the TI Europe is fully exposed, revealing old paint that has peeled away and become encrusted with marine growth after years of continuous operation. The core maintenance process begins. After the surface is grit-blasted clean, the crew uses specialized lift platforms to apply a fresh coating to the entire hull. The upper hull is sprayed with Euronav's signature white finish, while the bottom, the area constantly underwater, is coated in a deep crimson. This is a specialized anti-fouling paint, designed to prevent marine organisms from attaching to the hull. This reduces hydrodynamic drag, thereby optimizing fuel efficiency during transit. Once the painting is complete, millions of gallons of seawater are pumped back into the dock, and the TI Europe slowly rises in its new livery. The dock gates open, and a careful stern-first towing operation is conducted, guiding the giant out of the cramped confines of the repair yard. Escorted by tugboats, the TI Europe gradually makes its way toward deep water. The ship is now ready to resume its mission, carrying over 3 million barrels of crude oil per voyage, playing its vital role in maintaining the global flow of energy. The Ulsan shipyard is one of the largest shipbuilding facilities in the world, operated by Hyundai Heavy Industries, HHI, in South Korea. It follows a rigorous shipbuilding process that ensures maximum efficiency and precision. The process begins with the installation of the engine, the heart of the vessel. A massive two-stroke diesel propulsion engine and generator unit is hoisted directly into the open machinery space. The appearance of the colossal crankshaft reveals the staggering scale of this machine, the powerhouse that will drive hundreds of thousands of tons of steel across the ocean. Next, the dry dock is flooded during a temporary floating phase, allowing the hull to be moved flexibly to optimize assembly space. Segment by segment, the joining continues as the hull gradually lengthens and rises, clearly forming the silhouette of a Neo-Panamax vessel, featuring a signature open-top cargo hold design, optimized for container transport. The superstructure components appear one by one to complete the ship's profile. First is the engine casing system, prominently featuring the signature W logo of the Wanhai shipping line. Following this, the deck house, the nerve center for navigation and crew living quarters, is hoisted as a single block and welded securely onto the deck. The shipyard construction phase concludes with the flooding of the dry dock for the launching ceremony. The vessel is then guided out of the yard by tugboats. The video wraps up with sea trials, where the Wanhai, a 01, must operate at full capacity, performing zigzag maneuvers, emergency stops, and noise/vibration tests, before being officially commissioned for trans-Pacific shipping routes. This is more than just a ship. It is the culmination of modern shipbuilding technology. a vital link in the network connecting major global ports and maintaining the flow of world trade. Pretty amazing, isn't it? Tears and gashes from collisions or groundings are a nightmare for any ship owner. But instead of settling for a temporary patch, the engineers at Colombo Dockyard have opted for a bolder approach, cutting away the entire damaged section and replacing it with a brand new puzzle piece. Now, let's see if they can successfully pull off this massive structural repair. The liquid transport industry, carrying oil and chemicals, demands the strictest standards for safety and structural integrity. This footage of the tanker Sea Victory undergoing maintenance at the Odessa shipyard in Bulgaria reveals a quiet but vital side of the maritime world, the ongoing battle against oceanic corrosion. The process begins with the complex coordination of docking the vessel. This is a synchronized operation between the engineering team in the central control room and the tugboats on the water. Once the water is fully drained, the hull is exposed, encrusted with barnacles and algae. The crew utilizes ultra-high pressure water jets to blast the surface clean. Immediately following this is the grit blasting stage. Small metallic abrasives are fired at high velocity to polish the steel until it reaches a standardized surface roughness. This is not just for cleaning, it creates the mechanical anchor, or profile needed for the new paint to bond. The dust and noise levels during this phase are immense, requiring workers to be outfitted in fully sealed protective gear. The propeller and rudder systems undergo rigorous inspection. Propellers often show signs of pitting caused by cavitation. Engineers perform manual grinding and polishing to restore the blade's profile, ensuring optimal propulsion efficiency and reducing hull vibration during transit. The glare of welding sparks and oxygas cutters signals that damaged steel sections are being cut out and replaced with fresh, high-strength plating. Once the steel is clean and dry, industrial sprayers apply the coating system. This is more than just a cosmetic touch-up of the signature red and blue colors. It is a complex composite of anti-corrosive primers and biofouling protection. This ensures the ship glides smoothly through the water, significantly saving fuel upon its return to the ocean. Parallel to the hull work, mechanical engineers service the massive gears, anchor winches, and oil pipelines. Every detail, no matter how small, is stripped of rust, re-greased, and calibrated to ensure flawless operation in the harshest sea conditions. In the final stage, the ship's exterior is perfected. The vessel's name, Sea Victory, and its port of registry, Valletta, are repainted with sharp clarity. Simultaneously, systems such as ventilation and the funnel are refurbished. This entire sequence requires seamless coordination between multiple specialized teams, maintaining the schedule even when weather conditions are unfavorable. As the final checks are completed, the floating dock slowly submerges, seawater rushes in, and the ship regains its buoyancy. Assisted by tugboats, the Sea Victory departs Varna, passes the lighthouse, and heads into the open sea, ready for its next mission. This maintenance cycle is a testament to the high technical capabilities of the Odessos shipyard, ensuring both maritime safety and peak operational performance. Have you ever wondered why luxury yachts can glide so smoothly and swiftly? The secret lies right beneath the hull, where a mechanical miracle is taking place. This is a fully retractable propulsion system. Normally, when a yacht is under sail, a fixed propeller creates significant drag. But with this design, at the touch of a button, the entire drive unit lowers into the water, rotating 360 degrees for flexible maneuvering, and then completely disappears back into the hull when it is no longer needed. To see the true advantage of this technology, look at the Baltic 130 super yacht, the result of a collaboration between Baltic Yachts and Hundestead, setting a new industry benchmark. Hiding. The propeller leaves the hull surface perfectly flush, minimizing drag and increasing speed by over 0.2 knots. An incredibly impressive figure in the maritime world. Beyond the speed boost, this system ensures exceptionally smooth operation, with virtually no noise or vibration. It is a solution that is both brilliant and provides a truly luxurious experience. This footage brings us a truly unique mechanical surgery. The subject this time isn't a typical cargo or cruise ship, but the Ramform Vanguard, a seismic research vessel brought into the Navantia shipyard in Spain for a major propulsion system upgrade. Owned by PGS, the Ramform Vanguard is essentially a mobile laboratory at sea, used to scout for oil and gas beneath the ocean floor. Its design is exceptionally distinct, a sharp V-shaped bow transitioning into a massive, 39-meter-wide stern, a configuration designed to tow a colossal network of seismic cables behind it. To increase its towing power and operational efficiency, the vessel was brought into Navantia's Dry Dock Number 4, a facility dating back to 1891, capable of accommodating super vessels up to 400,000 tons. The process begins with the underwater dismantling of two 80-ton azimuth thruster units, a task performed by a professional diving team. Every move requires absolute precision, as even the slightest error could damage the equipment or directly threaten the divers' lives. Once detached, the thruster units are hoisted from the sea by cranes and safely brought ashore. As the dry dock is pumped dry, the entire lower hull is revealed. The technical challenge immediately becomes apparent. Unlike standard long-hulled ships, the Ramform Vanguard's triangular delta footprint requires a specialized matrix of keel blocks. The weight distribution must be calculated and arranged in an entirely different pattern to keep the massive steel structure stable. Simultaneously, high-pressure water blasting is deployed to clean the hull. The core phase of the project begins. A new 120-ton steel section containing the housing for a third thruster has been prefabricated. A crane lowers this steel block to the dock floor. Here, engineers use a mobile hydraulic lifting platform to slide the module beneath the hull, slowly raising and pressing it into a pre-cut opening in the original ship. Every millimeter is aligned before welders lock the structure permanently into place. Once the new module is fused to the hull, the azimuth propeller systems, both old and new, are fully installed. The new hydrodynamic structure then undergoes rigorous inspection. Finally, the dry dock is flooded. The ramform Vanguard slowly regains buoyancy, ready to depart the yard at Cadiz. Now equipped with a more powerful propulsion system, the vessel continues its mission, towing its massive sensor nets to silently track black gold beneath the Atlantic floor. Ships aren't always built from scratch. Sometimes the fastest way to create a new system is to transform an existing one. The Olympic trophy is a prime example. Originally an ore carrier, it was converted into an oil tanker in just over 50 days. The cargo holds were retrofitted into sealed tanks, and the piping and pumping systems were completely reinstalled. Most critical was the ballast system, the deciding factor for stability, which had to be redesigned to handle the specific characteristics of liquid cargo rather than dry bulk. Every modification is tightly interconnected, requiring precise coordination between engineers, workers, and management. There is no room for error, as even a minor mistake can compromise the entire vessel. Upon completion, the Olympic trophy was no longer the ship it once was. It emerged as a completely new system, with distinct functions, performance, and value. This represents the true advancement of maritime engineering, not just repairing, but redefining everything. We have just completed a comprehensive journey, exploring nearly the entire life cycle of a vessel, from its conception in massive shipyards to its operation, maintenance, repair, and even its conversion into an entirely new system. Through these stories, it is clear that every ship is more than just a means of transport. It is the culmination of modern technology, precision engineering, and the seamless coordination of hundreds or even thousands of people. Once in operation, the vessel's journey continues through endless maintenance cycles. Tasks such as hull cleaning, anti-fouling, propeller inspections, and structural repairs play a vital role in maintaining performance and fuel efficiency. A single overlooked detail can lead to massive operating costs or severe safety risks. However, this comes with a series of major challenges. The cost of a single dry docking can reach millions of dollars, downtime causes significant economic losses, and divers face constant dangers while working underwater in dark, polluted, and high-pressure conditions. Furthermore, these activities carry potential risks to the marine ecosystem, if not strictly controlled. Because of this, the maritime industry is entering a phase of powerful transformation. The emergence of ROVs, underwater drones, and automated systems has opened a new path, one where humans are gradually replaced in hazardous tasks, while processes are optimized to minimize environmental impact. In parallel, advancements in design and engineering continue to boost operational efficiency, reducing drag and saving energy. Overall, the modern maritime industry is a complex yet dynamic system where engineering, economics, humanity, and the environment are deeply intertwined. In the future, driven by technology and automation, the industry will push even further, moving towards safer, more efficient, and more sustainable solutions to ensure the global flow of trade and energy remains steady. Thank you for listening to the end of our story. If you enjoy videos like this, please like, share, and subscribe to the channel so you don't miss our upcoming stories. Raw Machines says goodbye, and we'll see you next time.